I'll be going over some SAT math problems in two runs. One of them will be a realistic test-like run, and the other one will be a pedagogical run where I'll be spending more time in answering questions in more detail. And the problems I will be going over are a set of problems with no calculator, labeled 1, 2, and 3, and a set of problems with calculator going labeled 28, 29, and 30. Problems 1, 2, and 3, if you want to get a screenshot, read as follows. If 5x plus 6 equals 10, what is the value of 10x plus 3? A 4, B 9, C 11, D 20. 2. Which of the following ordered pairs xy satisfies the system of equations above? And the system of equations is x plus y equals 0, 3x minus 2y equals 10. A, 3 minus 2, B, 2 minus 2, C minus 2, 2, D minus 2 minus 2. A landscaper company estimates the price of a job in dollars using 60 plus 12 NH, where N is the number of landscapers who will be working, and H is the total number of hours the job will take using N landscapers. Which of the following is the best interpretation of the 12 in the expression? A, the company charges $12 per hour for each landscaper. B, a minimum of 12 landscapers will work on each job. C, the price of every job increases by $12 every hour. D, each landscaper works 12 hours a day. And the problems with potentially the use of calculator are: in the xy plane above, ABCD is a square and point E is the center of the square. The coordinates of points C and E are 7, 2, and 1, 0, respectively. Which of the following is an equation of the line that passes through points B and D? A, y equals minus 3x minus 1. B, y equals minus 3 times the quantity x minus 1. C, y equals minus 1/3 x plus 4. D, y equals minus 1/3 x minus 1. 29. In the system of equations above, A and B are constants. For which of the following values of A and B does the system of equations have exactly two real solutions? In the system of equations is y equals 3 and y equals ax squared plus b. A equals minus 2, B equals 2. B, A equals minus 2, B equals 4. C, A equals 2, B equals 4. D, A equals 4, B equals 3. And problem 30, the figure above shows a regular hexagon with sides of length A and a square with sides of length A. If the area of the hexagon is 384 square root of 3 square inches, what is the area in square inches of the square? A, 256, B, 192, C, 64 square root of 3, D, 16 square root of 3. So I will get to starting on the board in my realistic test time run. And we can start it at this juncture. So now that I've solved these initially, let me take some care in explaining the tricky parts of some of these problems. So problem 1 was fairly straightforward. I just solve for x in this linear equation and then plug it into this one. Problem 2, slightly trickier. So we know by the first equation x and y are additive inverses, but the trick lies in that the second equation has a right-hand side that's not 0, and the test makers would like you to gloss over that fact and not account for that, but accounting for that and then excluding the choices that aren't additive inverses, it comes down to a choice between B and C, and then plugging in, we see B is the right one. Problem 3 is easily solved by dimensional analysis. So we notice that there is a cost that the entire expression is, and that cost is in dollars, but we notice that this number n is the units of 1/landscaper, and h has units of 1/hour. So in order to get dollars from 1/landscaper times 1/hour, let's make that hour more clear, we have to have the company charges $12 per hour for each landscaper. And in this problem, we use the fact that lines have equations of y equals mx plus b. We can solve for the slope of the line AC easily using the slope formula. And we know that since the diagonals of a square are perpendicular, the products of their slopes is -1. And we can deduce the intercept from of the line EB tracing backwards. And for the last problem, we simply solve for x, and in order to have two solutions, we need to make sure that the radicand here is positive.